Hello everyone, I'm Dr. Sumit Chauhan, Associate Professor in IT. Today we'll discuss a case study on efficient data management in e-commerce operation at Zenith Electronics. Efficient data management is crucial for smooth e-commerce operations. With the increasing volume of online transactions, Zenith focuses on organizing and optimizing data processes to enhance customer experiences and streamline business operations. This case study explores how Zenith Electronics implements innovative strategies to manage data effectively, ensuring seamless operations and improved performance in the competitive e-commerce landscape. Optimizing inventory management. To make sure Zenith Electronics manages its inventory well, they need lots of info about each product. This info includes things like the product name, description, supplier details, and how much of it they have in stock right now. This SQL query selects the product names and their respective supplier names from two tables, products and suppliers. It uses an inner join to connect the rows in the products table with matching supplier ID values in the supplier table. This means that only the rows where the supplier ID in the products table matches the supplier ID in the suppliers table will be included in the result set. The query then retrieves the product name from the products table and the supplier name from the suppliers table based on the matching supplier ID values. Now let's discuss this with the help of an example. Here we have two tables, products and suppliers. In product table, we have product ID, product name, supplier ID. And in suppliers table, we have supplier ID and supplier name. Now, when we inner join these two tables on the basis of supplier ID is equal to supplier ID, we're going to have a result where we have product name and supplier name, and supplier ID of the products table matches with the supplier ID of the suppliers table. Enhancing customer service, we need to know that what each customer orders, even if some have not ordered anything. This SQL query retrieves data from two tables, customers and orders. It selects the customer name from the customer table and the order ID from the orders table. The left join keyword ensures that all records from the customer table are included in the result set. Regardless of whether there is a matching record in the orders table, if there are no matching records in the orders table, null values are returned for the order ID column. The on clause specifies the condition for joining the two tables, which is that the customer ID in the customers table must match the customer ID in the orders table. Now in this we have two tables, customers and orders. In customers we have customer ID and customer name. In orders we have order ID, product ID, quantity and customer ID. The left join keyword ensures that all records from the customer tables are included in the result set, regardless of whether there is a matching record in the orders table. So, if there is no matching record in the orders table, null value are returned for the order ID column. Streamlining shipment processes. Making shipment processes smoother means having the right details to follow orders being shipped, even if some shipments are not connected to current orders. This query retrieves data from two tables, orders and shipments. It performs a right join operation, which means it selects all records from the shipments table and only the matching records from the orders table based on the common column order ID. If there are no matching records in the orders table, null values are returned for the order ID column. The query selects the order ID and shipment columns from both tables and returns them as the result set. Now let's discuss this with another example. We have two tables over here, orders and shipments. In orders we have order ID, product ID, quantity, customer ID, and in shipments we have shipment ID, date and order ID. It performs a right join operation, which means it selects all records from the shipment table and only the matching records from the order table based on the common column order ID. If there are no matching records in the orders table, null values are returned for the order ID column. The query selects order ID and shipment ID columns from both the tables and returns them as the result set. Comprehensive sales analysis. To understand sales fully, we need info on all transactions, even ones without returns or records of initial sales. This SQL query combines data from two tables, sales and returns. Using a full outer join, it selects two columns, sales ID from the sales table and return ID from the returns table. The full outer join ensures that all records from both the tables are included in the result set. Matching rows where the sale ID in the sales table matches the sale ID in the return table. If there are unmatched sales ID in either table, they will still appear in the result set with null values in the corresponding columns. This query retrieves sale ID and return IDs showing sales that we have been returned and sales that haven't been returned. Let's discuss this with an example, a full outer join. It selects two columns, sale ID from the sales table and return ID from the returns table. The full outer join ensures that all records from both tables are included in the result set. Matching rows where the sale ID in the sales table matches the sale ID in the returns table. If there are unmatched sales ID in either table, they will still appear in the result set with null values in the corresponding columns. Marketing strategy development. We need to gather information to understand what products people prefer in various areas, even if those areas are not connected. This helps us create a marketing plan. This SQL query combines data from two tables, products and regions. It selects two columns, product name from the products table and region name from the regions table. The query uses a cross join to combine every row from the products table with every row from the regions table, resulting in a complete set of combinations showing each product paired with each region regardless of any specific relationships between products and regions. This can be useful for analyzing product preferences across different regions. Now let's discuss the cross join with the help of an example. We have two tables, products and regions. In products, we have product ID, product name, supplier ID, and in regions, we have region ID and region name. Now, it selects two columns, product name from the products table and region name from the regions table. The query uses a cross join to combine every row from the products table with every row from the regions table, resulting in a complete set of combination showing each product paired with each region regardless of any specific relationship between the products and regions. This can be useful for analyzing product preferences across different regions. Through strategic use of various types of join in their DBMS, Zenith Electronics has significantly enhanced its operational efficiency, customer service, and strategic decision making. Thank you.